Okay, here we go, I believe. Yep, I'm rolling. So, again, if you are a person that, yes, what I do in class, hey, teaching moment, I'm up and rolling. You can always go to the book as a supplement because there will be examples that are worked out there. You can also go to Canvas modules. I will post notes there, videos. And then if you want me teaching, remember it's West High-Jody Kennedy on YouTube. All right? I like to use my monitoring progress. And if you were in the book, these are on the bottom of the page. You do not have to follow along. And we're just going to simplify some square roots. All right, and simplifying some square roots. For example, if I was looking at the monitoring progress, this is a number 2. And it is a square root of negative 12. Our number 3 is a negative. And then there is a number 4 in there as well. I do also have a PowerPoint in Canvas modules, which has more examples as well. But what we're going to start out with is the beginning of this section. It's just simplifying your square roots, okay? So when I look at number 2, it ties into what I told you we need to have in our memory banks, is that negative square root is really the I, and then I squared equals a negative 1 is going to come into play later when we get into adding and subtracting our complex numbers. So, starting with my number 2 up here as an example, we were just saying that a negative under a square root is really a what? Very good. And then we're going to look at square root 12 and break it down if we can. It's not a perfect square number though, is it? No, it is not a perfect square number, so we have to either do like the little cake method or the little, I like to do a Christmas tree method, where we're going to do our factors of 12. I like to think about the perfect square factors of 12. 6 and 2 are factors of 12, but not a perfect square. I would do 4 and 3. It's not wrong to do 6 and 2. It just, when we do 4 and 3, which one is the perfect square there? 4. Very good. So when we look at it, the square root of 4 is really what? 2, so that's going to come out. And then this 3 is going to stay underneath. So my answer is a 2i square root 3. Now, some of you might say, how come we didn't do a plus minus on this one? Well, we weren't solving for an x squared. Okay? So when you're solving equations and you do have an x squared equals that square root of negative 12, we would have put the plus minus. But since we're just simplifying a square root, we don't have to do a plus minus. It's just simply an answer of 2i square root 3. Okay? No plus minus. Only if you have x squared equals, if it's an equation and you have a variable squared, then we add the plus minus. So if we look at the next one, same sort of thing, except for we do have a negative out front. We don't distribute negatives, okay? We just take the negative and say, oh, a negative underneath is really a what again? An I. So we really have a negative I because that negative is there. This gives me the I. And then if I say square root of 36, that is a perfect square, correct? And what's the square root of 36? Very good. So then this one ends up being a negative 6i, and it stays negative because that negative was outside. Okay? This negative doesn't go away, it just goes to the answer. That I is goofy here. And it just stays with our answer. Okay? If I look down at number 4, this 2 is going to be part of our answer. Okay, right now it's really 2 times whatever this negative square root 54 is going to break down to be. Again, if I break down, we know that a negative under a square root is what again? I. Good. So we have a 2i. And we want to start breaking down 54. What are some factors of 54 that might be a perfect square? 9 and? Nope, bigger. 6. Yes, 9 and 6. Square root of 9 is really what number? Square root of 9? 3. So we really have a 2i times a 3. 6. Is it going to break down? No, because what are factors of 6? 3 and 2. Both of those are prime numbers, right? So we're going to leave it as a 6. And the only thing is, it sounds kind of goofy to say 2i3, right? So what do we really get? Yeah. Okay. Whoopsie. So, we just learned that a square root of a negative is an imaginary answer, and then we break down our radicals like we normally would. Okay? All right, there's another type of problem that I don't know if it's in our book or if it's even in our PowerPoint, but somebody had it in their notes yesterday. It might have been in the PowerPoint then, because they were taking notes from their PowerPoint. This is an example that came from the PowerPoint. And it was something like this. It was like a negative, let's say we have 5 times a negative 15. Okay? So now what we're looking at is we're kind of getting into the next section where you're going to add, subtract, multiply, or divide. This is multiplying, but again, when we think about this, we want to take the i's out first. Uh-oh, my pen's kind of being a little goofy. And again, I didn't invent these imaginaries. I just know the rules of the imaginaries. So when I say this, it is actually what you want to do. It's kind of like that PEMDAS business. When we were learning that, you learned that you do parentheses, exponents, the order of operations business. So the same thing applies for these imaginaries, that you're going to take the i's out first. All right? For me, I always think about self-defense. I took one class at Iowa State because it was kind of, a girl walking on campus by herself. They would say, carry your key like this and jab them in the eyes, jab them in the throat, step on their feet, run, scream, because this was before cell phones. So when I always say this, I always think about my self-defense class, but take the i's out first. So when we do that and take the i's out first, I really have an I square root 5 times an I square root 15. And then when I look at that and I say, okay, I took the i's out and I ran really fast. No, that's my self-defense class. Anyways, we multiply like things. So when I say like things, I'm saying an I times an I is really an I squared. My square root 5 times my square root 15. You can multiply it and get a number if you so choose. Or we're going to break down those numbers anyhow and try to simplify, right? So can I just leave it as a multiply and simplify from there? We can, okay? But now remember, there were 2 things that I told you to remember. Yes! We had the square root of a negative was the I, and then the I squared was what? A negative 1. So we are using the second thing that I said that we wanted to put in our memory banks. I squared equals that negative 1. So when we go and finish our answer, this is really -1 out front now because I squared is -1. And then if I think about breaking down, 5 doesn't break down. How do I know? Because it's a prime number. 15 does break down. And what are factors of 15? 3 and 5. So the premise behind these square roots, okay, if I were to multiply 5 times 5, that's 25, right? So for every 2 of the same factor that we have under a radical, because right now we do still have that 5, 15 broke down to be a 3 times 5. For every 2 of the same factor, 1 comes out. So for every 2 that I can cross out that are the same factor, 1 comes out. Because really 5 times 5 is 25. Square root of 25 is 5. So for every 2 of the same factor, 1 comes out. The 3 is going to stay inside. So I really have a -1 still. I'm bringing a 5 out. I have a square root 3 still underneath. So really, what's my answer? Well, what's -1 times 5? -5. And we said negative, and I forgot to write my negative. Okay? So if we run into 2 negative numbers multiplied together under those square roots, we have to take our i's out first. And then we multiply like things. I times I is I squared, just like x times x is x squared. Square root of 5 times square root of 15. You can multiply it and break it down, or we can leave it as a multiply and then break down. Either or, okay? We would still end up with the same answer. For every 2 of the same factor, 1 comes out. That 3 stays underneath because it's prime. I squared is -1. That's one of the 2 important things I said we needed to put in our memory banks. Okay? I's out first so that we all get the same correct answers. All right? Very good.